Welcome. Today we will learn about a program solution of a mathematical problem that is called Armstrong. Today we will learn about how we can check whether a given number or provided number is Armstrong or not. So first of all, we will go to the dev C++ to understand what is the logic behind the Armstrong number or which numbers are called Armstrong number. We will have to create a new project. As multiple times we have discussed before, we have to select here console application, C++ project. We are typing here Armstrong number. Name of the project. We will have to save the file project. The default line of codes are already written here. I am going to save the file that is called Armstrong number, etc. Okay. The key concept behind the Armstrong number or the formula or the logic of the Armstrong number is as we have to discuss. A number is called Armstrong number if the sum of its cubes of the given number's digit is equal to the equal number. We can simply say if digits cube sum. Here are the two parts of the Armstrong number checking. First of all, we will have to take the digits one after another. Then we will have to get cube of these digits, and accumulatively we will have to sum up all the cubes that are taken from the digits of the given number. Then the last step, algorithm's last step, is to check. Here we have say if the digits cube sum of a given number is equivalent to the original number. We can say that if the digits cube sum is equal to input or original number, then it is called Armstrong. Let's say if we say that 371 is the input and we are going to take the cube of first digit, that will equivalent to 3 into 3 into 3. The cube of second digit will be the equivalent to 7 into 7 into 7, and the cube of third digit will be equivalent to 1 into 1 into 1. These are the three cubes, and if we say that we are going to sum up these cubes and this is also equivalent to the 371, then we can say that 371 is the Armstrong number. Later on in this lecture, we will also do a special algorithm. We will practice a special line of codes that will help us to check the Armstrong numbers from 1 to the up to n series of the natural number, because in multiple lectures, video sessions already you have seen the commonly discussed number is 371 or 153 and so on. We will take a formula to get the all or maximum Armstrong numbers from the 1 to n. Okay. To implement this algorithm, what we will have to do? First of all, we will complete the declaration statement. As multiple times we have discussed in various lectures, we will have to require the num variable that is mandatory for taking user input. This variable will be used to take the user input. Next, the variable will be the remainder variable or RAM variable. This will use to store the remainder of the digit numbers. Later on we will discuss its purpose and working in brief. And this is the temporary number, that is declared temporary variable, that is used to hold the value of original number. And sum is equal to 0. This will called variable initialization. This sum variable will be used to accumulate the result of cubes into a single variable, so that it is initialized by the addition identity, that is 0. Okay, now we are going to take the input. Here we will print a message, enter number. Simply we will save it into num. These are the standard line of codes that all of you must have already understanding. Okay, now we are going to implement the logic of the Armstrong number in using while loop. First of all, we will take a copy of the input number in temp. What's the purpose of taking the copy of input number? This will later on fully elaborated. We will say that while temp is greater than 0. What's the philosophy behind taking the digits of a number, or how we can accumulate cubes of a digits from a particular number? The philosophy behind the scene is that if we suppose that we have the number 457, then in each iteration we have to collect the last digit from the number, which will with the 4 5, this last digit will the 7. How we can obtain 7 from 457? Because 457 belongs to the decimal number system, so if we will take remainder of 457, the remainder of this number will be the 7. This is the last digit of the number, and later on we will have to reduce this number by the last digit. This will get by the division of the number by its base. Okay, we will go through the code, and each and every line will self-explanatory, and we will discuss. We will have to collect first of all remainder, that will equivalent to temp modulus 10. Here what is going on, we are taking last digit, because last digit is the remainder of the particular number by its base. After taking the last digit, we will have to sum its cube in the sum variable. Sum is equal to sum plus or rem multiplied by rem multiplied by rem. Here these line of codes are required to be elaborate. We are taking here the cube of digit. What is the digit? Digit is the remainder taken by the number modulus by its base. Again, clear this concept. Remainder is the last digit that is taken by the remainder of the number by its base. Base is the 10. Okay. After taking this, we are going to accumulate its cube. Calculating here cube, that is equivalent to multiply the remainder 3 times and summing it up, adding it up into the sum variable. Okay. Later on we will have to reduce this number, as we have discussed before. We have to reduce this number by its base, so it will skip the last digit from the number. Just we have to type here temp is equal to temp divided by 10. At the end of this, by the end or completion of this while loop, we will have accumulatively sum of digits of a given number in sum variable, so that we will compare if sum is equal to num, that's the original number, then we can say that cout number is Armstrong, else we will have to print cout number is not Armstrong. These are the two messages that will appear. Okay, we are going to again discuss this, the entire philosophy or logic. Entire logic lies here, that is their number is Armstrong or not. The procedure is simple, very simple. First of all, we will have to take the last digit. The formula to take the last digit from a number is to take a remainder of the number from its base. Then in second step, we will calculate the cube of this last digit or the remainder of the number and sum it up in the sum variable. In the third step or the last step in iteration, we will reduce the number, so that the next time the number 7 will not obtained by the remainder of the particular number. Next time it will return as 5, next time it will return as 4, and at the end the temp variable reduced up to 0, so that we have to condition here while temp is greater than equal to 0 or greater than 0. This process will repeat it. taking remainder, taking its cube, summing it or adding it up in the sum variable, reducing the number by 10. At last we will compare it. Either this number is equivalent to the sum, provided number is equivalent to the sum. If this is true, then number is Armstrong, otherwise number is not a Armstrong. So let's check it by compiling the code. Here giving us error of cout. We have also delivered a detailed lecture of using namespace or using a standard namespace. Std, because C and cout objects are belong to the from the standard namespace. Okay, we are getting here the number 371. The number is Armstrong. Here we can clearly see the message. Here this is the input line, this is the output line, which is telling us that C371 is the Armstrong number. Okay, if we run it again, the code result may be different according to the provided input. We can again see the number is not a Armstrong. Okay. In the start of the video session, we have discussed that we can also discuss how we can get different numbers from 1 to up to nth number by taking the same algorithm. For this purpose, we just have to encapsulate the outer loop in some kind of inner loop, and we say that int I is equal to 1. We are going to check Armstrong numbers from 1 to, let's suppose, 10,000 or 100,000 I plus. In this outer loop, we are going to encapsulate the entire Armstrong code. This is the entire Armstrong checking number code. We are just here to print the number, else we will skip or eliminate. We are going to here print the number cout I here. Okay. Later on we will have to say that temp is equal to I each and every time. Temp is equal to I, and here we will have to compare I. Okay, anything more required to the change? Let's start the program, or we will have to also skip these lines of codes. Compile and execute while temp is not equal to 0. Here semicolon is missing. Okay, compiling the code. Here sum is equal to 0. So you can see here the code is compiled runtime, so that there is some kind of confusion. Each and every time we will have also do the same thing that is going on in the clean code for the single Armstrong number check. We can see here, if we compile and run the code, it is printing 407, the last Armstrong number from 1 to 100,000. I think 100,000, 100,000. We can say that 100,000, then the result is the same. So the conclusion is that up to 100,000 the Armstrong numbers are just 5, 153, 370, 371 and 407. So nice of. So keep our channel subscribed for latest update. Later on we will discuss how we can count the digits of a number using while loop. The same line of codes will be repeated in the same next video session, where we will see how we can count or sum up the digits of the number. That will increase the understanding of our Armstrong number and palindrome numbers. Okay, thank you.